Hi everyone, in this video I'm going to discuss questions on functions. It involves all the subtopic in the topic function, that is relation and functions, and type of functions, composite function, and also the inverse functions. First of all, we will look at this quadratic function. Express the f(x) equals to 1 minus x squared in the form of a x minus h squared plus k. So we must know that actually this form is can be obtained by completing the square. And after you get a quadratic function in this form, you can actually get its minimum or maximum point by looking at the a. If the a having the positive sign, all right, you will have a minimum point, which your quadratic graph will be in this shape. And if your a is a negative value, means that your graph will be in this form, that is having the maximum point. And the maximum point and minimum point can be obtained by finding the value of the h and the value of the k, the same thing as if our graph or our function having the minimum point. Now we need to find the maximum point after we have expressed in this form. So this is quite a direct question. First of all, I would like to make this function, the function given here, into its form in the a x minus h squared plus k. So we have to do completing the square. Firstly, I'm going to factor out the negative so that the coefficient of the x squared become positive 1. When you factor out the negative, you will have x squared plus x minus 1 in the bracket. Then all the completing the square procedure, we're going to do it inside the bracket here. First of all, copy down the first two terms and add in the two bracket, that is plus bracket square minus bracket square, and the constant always will be at the end of the statement. Then after that, we need to fill in this bracket by taking the coefficient of the x, that is a positive 1. All right, and then both of them then divided by 2. All right, so later on we are going to simplify the first three term and write it into the form of x plus 1 over 2 square. 1 over 2 is come from here with the sign of positive. So simplify the constant. I got negative 1 over 4 minus 1. Then again we simplify the constant first before we multiply the negative inside. So we have a negative 5 over 4. After we have done this, I'm going to multiply the negative into the factor inside. That is, we got the negative of x plus 1 over 2 square plus, because a negative multiplied by negative, you got positive 5 over 4. So based on the form, okay, we compare to this form, a x minus h squared plus k. A is having the value of negative 1. Since a is negative 1, which is less than 0, our shape of the graph will be having the shape like this, that is open downwards, and the the maximum point will be given by the hk. So just reverse the sign of the positive 1 over 2, you get negative 1 over 2, and directly take this value to be the y coordinate of your maximum point. So we need to answer the question, find the maximum point of the expression. So we need actually we have a we just need to answer the question, writing down maximum point is negative 1 over 2, 5 over 4. For the question 2, again, we are dealing with the quadratic functions. That is a 12x squared minus 3x plus 5. And for the question A, we need to determine the minimum point of the f(x). So to determine the minimum point, again, I will stick to the completing the square. I'm trying to factor out the 12. Okay, make it the coefficient of the s squared to be 1. And then when you factor out the 12 here, you will get a 1 over 4x. So 3 divided by 12, simplify, you will get 1 over 4x plus a 5 over 12. So now the completing the square, I'm going to do it into the inside this bracket. Copy down the first two term, add in the two bracket. One is the positive bracket square, the other one is negative bracket square, and the constant I will put it at the end. So what should I fill in this bracket? I'm taking the coefficient of the x, that is negative 1 over 4, and divided by 2, you get negative 1 over 8. The same thing over this bracket. Simplify the first the first three terms. The first three terms here, it can be written as x minus 1 over 8 square, and we simplify the constant. After that, we multiply the 12 inside. We have 12 of the x minus 1 over 8 square and plus 77 over 16. And taking the 77 over 192 multiplied by 12, you have this. After that, our function has been written in this form. Compared to the form that we learned in the first question, we have a minus h square, x minus h square plus k. To we want to determine the minimum point. Now the question already told you that it has the minimum point. So the minimum point, you just answer like this. The minimum point is taking the value of this negative 1 over 8 and reverse the sign, you got 1 over 8, and directly take this value as your y coordinate of your minimum point. That is 77 over 16. To sketch your graph for the question B, we need to have our Cartesian plane. To sketch the graph of this, right, we just plot the x as having the 1 over 8 unit. Okay, so as if that this is 1 over 8, and 77 over 16. This value is roughly 5. I will just put it here as a 5. So my minimum point will be somewhere here. And this is a quadratic, right? So you are going to sketch a parabola, which is open upwards because this point is a minimum point. So our graph will become like this. It's a parabola, passes through the minimum point and go up again. Okay, so you can just label this as your y equals to fx. And now you can see there is one important point over here, that is your y-intercept. All right, you can get a value by substituting x equals to 0. When you put x equals to 0, we have a 12. 0 minus 1 over 8, that will be negative 1 over 8 square plus 77 over 16. Just calculate with the calculator. And this is equals to 5. I think I did something wrong over here. This value, I should put it as a 77 over 16. And here, when the x equals to 0, meaning that when what is the y-intercept at this point, the y is actually 5. Okay, at the y-intercept, y-intercept is at the 0, 5. So minimum point is at the y 77 over 16. That will be 4.8 something. Yeah, it's very close to 5. This is our y equals to fx. Let's scroll up and look at the question C. Determine the domain and the range of the fx. So based on the graph, we can determine our domain. Domain is from negative infinity up to infinity. For any of the quadratic function, if let's say the domain is not restricted, meaning that it is always from negative infinity to infinity. You can see the graph is keep on going to the left and going to the right non-stop, and in the middle there is no any broken point. Okay, and then for the range we will look at the lowest point. The lowest point of the graph is 77 over 16. So our range will start from the 77 over 16 and up to the infinity, because the graph is just keep on going up like that. You can see these two, you can put arrowhead to show that the graph is going up non-stop. So this is our domain and the range. Alright, this is a similar question to the question 1 and 2. What is different is now you need to determine the either it happened the minimum or maximum point, and then sketch this graph. So again, I'm going to express the fx into this form, which are by completing the square. Firstly, I will try to arrange my fx into this form. leading term will be x squared, and followed by x term, followed by the constant. To do completing the square, firstly, we need to make sure that the x squared having the coefficient of 1, meaning that taking out the negative 3, I got my x squared minus 12 divided by negative 3, I got negative 4x, and then negative 8 divided by negative 3, I got positive 8 over 3. And now I start to do completing the square. Copy down the first two terms, add in the two brackets, and then the constant. And now you need to fill in this bracket by taking the coefficient of the x, that is negative 4, and both of them going to be divided by 2. After that, the first three terms I'm going to simplify into x minus 2 squared. The negative 2 is come from the negative 4 divided by 2, and simplify the constant, you got negative 2 squared, that is negative 4, plus 8 over 3. Alright, then I simplify the constant first. I got it negative 4 over 3. Now you have done the completing the square, you can multiply the negative 3 inside. So your fx will be negative 3 multiplied by x minus 2 squared. Negative multiplied by negative, you got positive 3 multiplied by 4 over 3, meaning that you got a positive 4. So this you already done the question A and determine whether the minimum or maximum point of fx. For the question B, to determine either it happen maximum or minimum, okay, we will look at the value of the A. Since the value of the A is equals to negative 3 is less than 0, so our graph is in this shape, having the maximum point. It's a graph parabola which is open downwards. So we say that the minimum point determine the minimum point. Yeah, the maximum point or minimum point. So the maximum point here will given by the value of the 2. Taking the negative 2, reverse the sign, become positive, and then the y coordinate will be 4. So the maximum point, you just answer the question. The maximum point is 2, 4. Alright. Then question asks us to sketch the graph. So from the information that we got, maximum point is 2, 4, right? So just sketch a 2 at x and then 4 unit for the y. So 2, 4 will be here, okay, somewhere here. And now you need to sketch it in this shape. It's a parabola and then it's open downwards. So the graph will be like that. And you can see now there are 3 important points over here. You need to plot it out. So the first point, this is a y-intercept. You can just put in your x equals to 0, which when the x equals to 0, your y will be negative 3 multiplied by negative 2 squared plus 4. So you have your 4 multiplied by negative 3, that is negative 12. Negative 12 plus 4, that will be a negative 8. So when you calculate the f0 equals to negative 8, so you will feel weird, right? Because our y-intercept that we sketch here is passes through the y-axis at something as somewhere slightly less than 4. So our graph shouldn't be this shape. It should be a little bit how to say, the gradient should be higher, and I would like to modify my graph into this one. So I should draw my graph in this shape and erase this one, because from the f0 equals to negative 8, I know that my graph should pass through negative 8 when the x equals to 0. So here you can see 2 more points that you can find, letting the y equals to 0. Putting the fx equals to 0, you got negative 3 x minus 2 square plus 4 equals to 0. From here, we solve for the y. Okay, so when you solve for the y, this will be equals to negative 4 over negative 3, which will be 4 over 3, and x minus 2 is a positive negative 2 over 3. After that, x will be equals to positive negative 2 over 3 plus 2. Or you always can give your answer in a decimal. Okay, that will be, so after I simplify by my calculator, I got 2x. The first x is 0. This means that this point will be a 0.845, and this x-intercept will be a 3.155. Alright, then you should label this as your y equals to fx. For this question 4, a function f is defined by fx is a cubic function, x cubed minus 4x squared minus 3x plus 14. If the curve of the function f intersect the x-axis at the x equals to 2, x equals to h, and x equals to k, find the value of h and k. Meaning that if let's say this f intersect at the x-axis, meaning that these all are the roots of the function, okay, of the equation. So we can say that the factor is a x minus 2, x minus h, and the x minus k. Those three linear factor will be the factor of the fx. And now the question asks us to find the values of h and k. So one of the factor we already know is x minus 2. We can use a method of long division to divide it by the x minus 2. Then in our quotient, we will get one quadratic factor. So from the quadratic factor, we can obtain the h and k. So here is the method. Taking the function divided by x minus 2, okay, I will get x squared. X squared multiplied by x, you get x cubed, and you got a negative 2x squared. Then minus, you got a negative 4x squared minus a negative 2x squared. There is a negative 2x squared, because a negative negative will produce positive, so you got a negative 4x squared plus 2x squared. And take down this, bring down the negative 3x and the 14. Taking the negative 2x squared divided by x, that will be negative 2x. So you will have a negative 2x squared multiply negative 2x multiplied by negative 2, that will be positive 4x. And keep on repeating the same procedure. You get negative 3x minus 4x, that will be negative 7x. Alright, and then bringing the 14 down, you got positive 14. Negative 7x divided by x, you got a negative 7. Negative 7x plus 14. So there is no remainder because x minus 2 is your factor. Meaning that our fx can be written as x minus 2, x squared minus 2, x minus 7. If we keep on factorize, we will have x, and seems like this quadratic factor cannot be factorized. So I would just solve it, because the question A stated that the x-intercept having the x equals to 2 and x equals to h and x equals to k. So I'm going to solve for this equation, letting the fx equals to 0. Then I got my first root will be x equals to 2, and the second root you always can get it by equating this quadratic factor to the 0. Okay, then we are going to solve for this. Since it cannot be factorized, I'm going to use the formula that is x negative of negative b will be negative 2 plus minus square root of b squared, that will be negative 2 squared, minus 4ac, and the c will be negative 7 over 2a. Then simplified it, you got a 4 plus 11, that will be 15 divided by 2. So this will not be 15. Oh, sorry, this is 28, right? It should be 32. and you have can simplify it by simplify the surd of 32. Surd of 32 32 is consists of 8 multiplied by 4, so it will be square root of 2 square root of 8, yeah, okay, and then divided by 2. So factor out the 2, you will have a 1 plus minus surd of 8, yeah, by cancelling off the numerator and the denominator. Okay, cancelling off the 2, so simplify further, you will have a 2 surd of 2. So from here we can say that this is our x. So one of our x is h and the other one the x-intercept is k, right? So now we can say that the h, okay, h might be 1 plus 2 surd 2, and the k has to be 1 minus 2 surd 2, or the other way around. For the question B, we're going to sketch the graph. So we know the 3 roots. One of the root will be 2, the other root will be 1 minus 2 surd 2, and the third root will be 1 plus 2 surd 2. So this value 1 plus 2 surd 2 is if you convert into the decimal, you got 3.828, and 1 minus 2 surd 2, if you convert it into decimal, that will be negative 1.828. So here, to sketch this graph, I'm going to plot those value, those point, for as if that this is your negative 1.828, and you have your 2, and you have your 3.828 is around here maybe. Okay, that will be 1 plus or you can label this as in a decimal. This will be a 3.828. So the graph will passes through these 3 points, and now you can look at the coefficient of the x cube. Coefficient of the x cube is 1. Okay, if your coefficient of the x cube for the cubic function is greater than 0, then your shape of the graph will be like this. Up, you go down, go up, and then go down, and then go up. If your a is less than 0, a is representing the coefficient of the x cube. If it is negative, meaning that your graph will be in this shape. Go down first, reaching a local minimum, and then go up, reaching a local maximum, it go down again. So now we have the coefficient is 1, right? It will take the first shape. Okay, we will have the shape like this. So we'll sketch the graph in this shape, and then in reaching a local maximum, it go down, reaching a local minimum, it go up again, passes through the 3.828. So this is a graph of y equals to fx. Since you have the y-intercept over here, you can always get the y-intercept value by putting the 0 into the x. If you put 0 into the x, the first 3 terms all will be 0, and you will have 14 here. Alright? To get the domain of the function, that will be negative infinity to infinity, because you can see that the endpoints, both endpoint is going to positive infinity and going to negative infinity. And for the range, you can see also this endpoint is going down indefinitely, so our range will be negative infinity up to infinity. For the next example, I'm going to determine the domain and range of this function. It's a quadratic function by sketching the graph. Okay, to sketch the graph of the quadratic in this form, firstly, I want to do completing the square to make it the maximum or minimum point obviously can be shown in the completing square. So firstly, to do completing the square, we have to make sure the coefficient of the x square has to be 1, and then after that we're going to copy down the first 2 terms, add a bracket square minus a bracket square and a constant, put it behind it. Okay, and then substitute the coefficient of the x into it, both of them divided by 2. This completing the square step I already explained to you all for many times already, so it should be okay for you. Now the first 3 terms, it can be simplified into x minus 2 square minus negative 4 over 2, that will be negative 2 square, that will be 4, Negative 4 minus 1, you will get negative 5. So since your fx now is in this form, you can look at the value of a, which is 1. If the a is greater than 1, greater than 0, meaning that the shape of the graph is having the minimum point. And the minimum point can be seen, can be obtained by taking this value, negative 2, you reverse the sign, you got 2, and then the y coordinate will be negative 5. So after we know all this information, now we can start to sketch the graph. Having your Cartesian plane, x and y axis, and now I'm trying to plotting the 2, as if that this is your 2, and negative 5 is somewhere over here. So at the 2, negative 5, I have a point which called minimum point, and I know that if I sketch a graph, I will have the shape like this, right? So I'm not going to sketch it yet because I do not know. I'm wondering that my graph will either passes through the negative x-axis, or passes through the origin, or passes through the positive x-axis. I'm not sure. So I want to get those value. I will try to find y-intercept. Finding the y-intercept by putting the x as a 0, you will have 0 minus 0 minus 1, meaning that your graph will passes through negative 1 here. So now you can sketch your graph. Passes through the negative 1, go down until reaching the minimum point, go up again. And the shape of the parabola is like this. Okay, this one can be better. You just sketch so that you have a very smooth shape. So this is a y equals to fx, and now I can see that my graph passes through 2 points. The x-intercept, you can find the x-intercept by letting the y equals to 0, putting this this form equate to 0. You will have x minus x squared equals to 5, x minus 2 equals to positive negative third of 5, x is equals to 2 plus third 5, or 2 minus third 5. So here will be 2 minus third 5, this point, and this point will be 2 plus third 5. Just label like this. Okay. From the graph, we can see that our domain is all the real number, or we can say that is from negative infinity up to infinity. And the range, you can see that the lowest point at the graph is negative 5, and it's include negative 5. And the graph is just going up non-stop, so the range will be end up by infinity. For this example, I'm going to sketch the graph of this function. It is a quadratic graph. Firstly, to sketch the graph, I would like to do completing the square, and so that I can determine its maximum or minimum point. Firstly, I factor out the negative 1. I got my x squared minus 2x minus 2. And completing the square is copying down the first two terms. Add a bracket square minus a bracket square minus 2. And I'm putting, substitute your coefficient of the x into the bracket, and then both of them divided by 2. So I've got my negative x minus 1 square minus negative 1 square, you got 1, negative 1 minus 2, you got negative 3. Multiply the negative in, you have a negative x minus 1 square plus 3. So from this function, we already do completing the square, and so that is now it presents in this form. So from this form, we can see that if the value of a is less than 0, since the value the a is negative 1 in this case, is less than 0, so this graph having the maximum point, and the maximum point is given by 1, 3. Taking the value of this, negative 1, reverse the sign, and then the y coordinate is 3. Now we can sketch the graph on our Cartesian plane. We plot the maximum point first, 1, 3, and the graph might be in this shape. It's a parabola shape, and now you can see that your graph passes through the x-axis, you can actually get this value by letting your y equals to 0. Putting your y equals to 0 and solve it, we will have x minus 1 equals to positive negative z3, and x equals to z3 plus 1 or negative z3 plus 1. So here will be your negative z3 plus 1, and this is a z3 plus 1. So there is another important point that you need to find out. That is your y-intercept. To find the y-intercept, I just put my x equals to 0, and I got my fx equals to 2. So this value is 2. Okay, so we have sketched our graph, and now we need to determine the domain and the range. The domain is from negative infinity to infinity, and the range, the lowest point of this graph is going down indefinitely, so our range will start from negative infinity, and the highest point for this function is 3, so the range will be from negative infinity up to 3 including 3. For this question, we deal with the quadratic function, that is fx equals to x squared minus 2x minus 3. And this time we are going to restrict, we have the domain condition, that is x is from negative 3 to 4. Determine its minimum value, and hence find its range, sketch the graph. So from this function, I'm going to do completing the square in order to determine its minimum point. So this I will just skip by recording. After I've done, I will record again. Alright, I have completed the square and got this form, and now you can see the value of the coefficient of the x squared is actually equals to 1 and is greater than 0. So you say that it has a minimum point, and the minimum point is given by 1, 4. Okay, 1 negative 4. Okay, reverse the sign of this, you get 1, and then follow this one, negative 4, directly take for to represent the y coordinate. So the question asks for the minimum value. Minimum value is referred to the y value. So minimum value is referred to the y coordinate of the minimum point, that will be negative 4. Just answer the question, and hence find its range. So if let's say you have the minimum value negative 4, meaning that you can get the range easily. That is, start from negative 4, okay, the lowest point of the graph, negative 4, and then the graph is going up indefinitely, so this will be end up by infinity. To sketch the graph, I would just plot the minimum point first. This is negative 4, this is 1, so this will be 1 negative 4. Now the graph will be having the parabola shape and passes through the x-axis at 2 points. So I can see that I need to find this 2 point. Okay, to find this 2 point, I can just putting the fx to be 0. Here I got the x-intercept. Okay, is first x-intercept is negative 1, and the other is x equals to 3. So we just can label this as negative 1, and this is equals to 3. And there's another point that you need to find out, that is your y-intercept. To get the y-intercept, I would just put your x to be 0. You can see that the y will be equals to negative 3 when the x equals to 0. Okay, now we refer back to the range, okay, to the domain. The question state that the domain is from negative 3 to 4. So negative 3, maybe we can, okay, is somewhere over here. I lengthen my graph. Okay, so this is a negative 3. I will just cut my graph at the negative 3, and at the 4 as well. So here will be your 4, right? Then you project a line to your graph. So you will cut your graph from negative 4. Okay, sorry, from a negative 3 to 4. The range later on we need to reconsider, because the domain is from the negative 3 to negative 4. The range might not stop at the, might not go up to infinity. So later on we need to reconsider our range. So here I would just remain this part, remain from a negative 3 to 4. And other than that, I will just erase it off, because the question just want the domain from negative 3 to 4. So I will have the graph like this, and now you need to get the y, the corresponding value of y. When x equals to 4, what is your y? Substitute the 4 into this function. So you get 4 minus 1, 3, 3 squared, that is 9. 9 minus 4, that will be 5. So this value is 5. And when x equals to negative 3, put the negative 3 inside. Inside here, you get a negative 3 minus 1, negative 4 square. You get a 16. 16 minus 4, that will be 12. Okay, so this will be the value 12. This means that our range is not a negative 4 to infinity. We need to rewrite our range. The range is from negative 4. Okay, is correct from negative 4 because the lowest point of this graph is at negative 4, our minimum point, and the highest point of this graph is 12. So the range has to be from negative 4 up to 12. This is my range. Followed by this example, find the domain and the range of this quadratic function. Again, we need to know the minimum or maximum point so that we can get the range correctly. Okay, so this is a negative 15. So to get the maximum or minimum point, I'm going to do completing the square again. Here I have the function in this form, x plus 1 square minus 16. Since the coefficient of this factor square having positive 1, so we have a minimum point. And the minimum point is given by reverse the sign of 1, you get negative 1, okay, to be your x coordinate of the minimum point, and negative 16 will be the y coordinate of your minimum point. Okay, so once you got the minimum point, you can find the domain and the range. The domain, okay, for any quadratic function, if the domain is not restricted, it is always from negative infinity to infinity. And the range is started from the negative 16 up to infinity. And next, the question asks us to sketch the graph. To sketch a graph, I will just sketch the negative 1, negative 16 first. Negative 1, negative 16. Negative 16 is very down here. Okay. And then after that, we just plot a quadratic graph, okay, in a parabola shape. And we will know that it will pass us through the x-intercept. Okay, x exists at 2 points. That is our root. To get the root, we can put in the function equals to 0. Okay, you take the x plus 1 minus 16 equals to 0 and you solve it. You will get the roots. So here you can see that our root will be x equals to 3 and x equals to negative 5. So negative 5 will maybe roughly here. It will pass us through this point and then it will pass us through the 3. So you can sketch your quadratic graph. Passes through the negative 5 and you go down. Yeah, this is the best that I can draw, and I'll label this as a y equals to fx. There is one more important point that I need to find out. That is my y-intercept. So substitute the x equals to 0, you get the y equals to negative 15. So this point is actually negative 15. Okay, so so tally with the domain and the range from the graph that we have sketched. Yes, it is correct. This is the last example for this video. I got a few more questions in my next video. I will just name this video as a part 1 for the reinforcement practice on the topic functions. So another 7 more questions in my part 2, the video part 2, will be discussing on the functions question that involving the quadratic functions and cubic function. Thank you for watching.